Good afternoon to all. In this video, we are going to discuss about case study regarding control system. In this video, we are going to discuss how the elements are tenable for control systems. Let us start from
Let's see about the linear control system. Linear control system is the control system and control theory based on the negative feedback. It is used for producing the control signal to maintain the process variable to decide the set point. For example, we take refrigerator. Refrigerator has a set of temperature at its desired temperature. We use a sensor like thermostat sensor used for predict the actual temperature, and also we use compressor motor for power amplifier.
So as we all know about quality control system, in control system, the control system manages manages devices and systems in two control loops. One is open loop and another one is closed loop. So open loop is used in the application which there is no feedback and error handling is required, and also it is very easy to maintain. And next one is closed loop control system, where closed loop control system is used in the applications where the feedback and error handling is not required. So this is the difference between the open loop control system and closed loop control system. And also the closed loop control system has a sensor which is used to do feedback the signals from the control system. So the block diagram reduction rule is very important method for the determining of the process and which transfers the functions to the complex system. It is very useful methods to stability the complex systems into the simple complex systems, and it is more stability to we can analyze the stability for the performance of the system easily. So signal flow graph is a diagram which represents the set of simultaneously algebraic equations. When applying the signal flow graph, first we have to take the linear differential equation into the algebraic equation in the Laplace transforms. Some basic elements of control system are nodes and branches. Nodes represents the variable or a signal. It has three types of nodes: input node, output node, and mixed node. And branch is a line segment which uses to connect the two nodes. So control systems can encounter various types of error. So there are many types of errors in the control systems, such as steady state error, transient error, overshoot, and instability. And these errors also has an cause, that is the factors that includes these errors or inaccuracies in the signal, and there are many limitations during the process. So as Varshini briefly said about the types of errors, I will be explaining them precisely. So the first one would be steady state error. So steady state error occurs when the device's output does not reach the desired output or the steady state position. And the next would be transient error. Transient error occurs during the transition period of the output, where there will be movement from one output to the another. And the next would be random errors. Random errors occur when there is any fluctuations or changes in the output state. And the next would be modeling error. Modeling error occurs when there is any damage in the mathematical instrument which is used to calculate the output values. And systematic errors occurs. Systematic errors is similar to random errors. Systematic errors occurs when the device or the system's components are damaged and you will not get the desired output. And the last one would be actuators and sensors error. So there would be actuators and so there would be problems while enabling the actuators and sensors also. So actuators are used to enable the input values and sensors are used to enable the output values.
Is there any threshold value for fixing the errors?
Yes sir, there are various formulas to rectify these errors. If the error value ranges from 0 to 1, we can use the damping ratio to find out the errors.
Sensors is defined as a device that converts physical stimulus into a readable output, and the role of the sensors in control and automation system is to detect and measure some physical risks, providing information to the control system. And there are 5 types of sensors.
temperature sensors, pressure sensors, level sensors, flow sensors, and proximity sensors.
So coming to actuators, actuators are the ways to that provides generates a motion by converting the energy and signals that enters into the system. So during this process, the system process will be in a linear mode or in a rotation mode. There are two types that is based on the rotation, like a linear and a non-linear modes. So some common examples of this actuators, we can say that stepper motors and jack screws, electrical motors, and many other. So coming to the application, this actuators can be applied in various fields like agriculture machineries and making some metal parts and in simulation of robotics. So with this application, there are some drawbacks for this actuator. Drawbacks means it is highly sensitive to the vibration and high speed, so it cannot be controlled easily.
So what is the function of actuator with respect to sensors?
So it is equal to the sensor, but it makes the movement using the signals and the energy that is given into the system.
Actuators are used to determine the input signals and sensors are used to determine the output signals.
How to detect the errors from the closed loop systems?
So the errors are handled by using feedback.
We can able to calculate the errors. So we conclude that so while placing the elements in control systems, so these are all the common measurements which will be needed for the control system. So thank you all.